Hello everybody, today we are going to talk about the function templates. As you can see, we have got here the code from the lesson 45 about the inheritance. So we have got here a class point and point to the create. Right now I would like to show you, as always, the problem that will be resolved later by the function templates, right? So we know why should we use something like that. We won't use only theory, we need also the practice, right? Okay, so look, we can have situation like that. I want to add two numbers, right? Let's make it as simple as possible. Let's add two numbers that are integers. So we have to return the integer. We'll call the function add, and we'll take two integer, variable 1, variable 2. And now we'll make this inline function. We'll just return the variable 1 plus variable 2. So right now we can easily do something like add and then send here the 2 and 5 to the output. Then we can just build and run the program and add here too. And as you can see, the numbers were added very well. But what will happen when I do something like that? As you can see right now, the result is also 5, even though I sent here the double number, right? Because, well, we had only that function to choose, and our compiler just changed 5.5 to the integer, right? He changed the type double to integer. So it means that, well, if we want to have the right result, we should also create something like that: double, 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 right? Something like that. As you can see right now, he doesn't know which function he should run because, well, I have got here one variable integer and the second double. So here I am taking two integers, here I am taking two doubles. So which one I should choose? I don't know. He doesn't know, so we have to choose one of them by doing something like that. Well, something like that to not change the result, right? Or we have to just do it that way, right? Or we can just do something like that. We can use the casting, right? And everything will work fine. But when we are using function, we shouldn't think about things like that, right? That would be horrible if I had to remember about things like that. So we have to create another function. So for example, I create function like that. The first will be double, the second will be, for example, integer. And I have to create another. For example, that guy will be integer and this guy will be double, right? And right now I can easily build and run that program and everything will work fine. But as you can see, we had to write 4 functions to achieve that thing. And now, well, you know that double, that integer is a big variable, right? It is taking memory. So it is taking 4 bytes of memory, this guy is taking 8 bytes of memory. Sometimes we don't need so big numbers, right? We could use the short integer or something like that. That would be enough for us. And then these guys here would be a bit slower, so we should create another function. And now I would like to show you something what is called that function templates. And this is something like generalization of functions, right? Generalization of functions. So we can just remove that thing here, and now we can say the word template. So we are creating a template. Then in the brackets like that, in the angle brackets, we can define our own type. This type is called general type. So we can do something like type name, and then we can, for example, do something like T. That T is the shortcut from the type. We can type here anything. This is our type, our name of type. Well, and well, I will just do something like T here, okay? And then I can use the type that I've just created here. It is any type that will be sent to our function. So I can do something like that: t at, then t var 1, t var 2, and then return the var 1 plus var 2. So right now I want to do what? I want to add two variables that are what? The same type, right? They are both the same type. So when I do something like that, it will work. When I do the double way, it will also work. But we can't right now send something like that, because here we just declared only one type, right? So how is it working? When he can see the two double variables, he's changing that t to double, right? Instantly. So it's very cool, right? We just written only one function, and it really works for also, for example, short integers and other things like that. When both types are the same. But hey, we can create more than one type. I can type something like type name t2, and now I will just change that guy to t2, and now I can easily add the double and int, or I can add the int and double. But as you can see, now we had the wrong result, because first we used what? We used the integer, then we use the double. So the first thing here is the integer, the second thing here is the double. So t2 is double, t is integer. So but I would like to have the double as a result always. How to do it? Well, first I would like to show you something. Normally when you use something like static cast, there is something like that angle bracket. They're very similar to that thing, aren't they? And here we are sending, for example, integer, then in the brackets we are sending, for example, 6.5, and this thing here will be changed to what? To the integer number. So static cast is really a function that is having something like that here. Now as you can see, the result is 6 here. So this is really a template, right? Static cast is really a function template. Here we can also specify what will be in t and what will be in t2 from above, right? We can say it. So we can do something like, hey, I want it to be, for example, the first guy must be double, and the second guy must be also double, right? Both are double right now. And as you can see, the result now is okay. So we can make it always working properly like that. Okay. So as you can see, we've just by creating one function template, we saved our time, right? That's the first thing. But this is the easy situation, and well, I didn't and I used that code here, that point, not by mistake, because I would like to show you something. What about doing something like add, right? Well, let's make it comment right now, and operation on points. I like to, for example, create 2 points. The second guy will be 50 and 3. I want to add the 2 points, so 10 plus 50 and 67 plus 3, so the results should be 60 and 70, right? So that should be our result. And now I am using our function here, right? The add function, and p1, p2. As you can see, we can't do it, even though that both guys here are the same type. So here we have the point to D, here we have the point to D, we're returning a point to D, but it's not working. Why? Because we didn't create the operator function that we talked about before. We created, but firstly I would like to show you another problem. Imagine now that we can't access that place here. we can't add that another function, the operator function. So how to deal with that problem? We can make something like template specialization for functions, and it looks like that. Template, and then we're just creating the two angle brackets, and we are not specifying the things here, right? And then point to the, then add, right, the name of our function. Then we are just specifying, so we are saying that this guy will be point to the for sure variable 1, point to the variable 2, and then we must return the point to the with new values, right? So what? Well, let's create point to d that will be temporary for us, and we'll use the function temporary set x variable 1 point to d dimensional variable 1 get x plus variable 2 get x. So we are getting x from variable 1 variable 2, and now we just need to do the same thing, but right now to the y value, and we can just return the temporary here. So now we can do something like that and send to the output sum dot get x and get y. So the results should be 60 and 70. Sorry, that's my mistake. I didn't use the operator that allow us to invoke functions, of course, that are functions that are not properties. So now it will work fine. As you can see, we have here the results 60 and 70, and of course we have got their messages from the destructors and constructors. So well, we don't need to worry about them. The most important thing is that, right? It's working cool, but we had to specify that because remember, we are imagining situation, we didn't have the way to get access to that place here, okay? That situation might happen because, for example, there's a license like that doesn't allow us change and other things like that. But well, you know what I wanted to show you here. Now, just as an exercise, let's just create that operator here. So what we should return? We should return the point to the. This guy is the operator function, so operator then plus, then we are saying what this what things will be added. So this will be the point to d, right? And this is the declaration. Now we have to define it here, right? And we can do it by saying what will be returned. Then we go inside the point to d. Then we are specifying the operator plus point to d. We'll call that guy object, and here we also need to create the temporary guy, and this time we'll set x that way. This, well, let's use this thing from here because we don't need to write so much. Then set this object that is actual guy, right? The same thing should be done here, plus the guy that will be sent to us by the operator function. So right now we can easily run, well, it's that way. As you can see, the result, we didn't return the temporary, of course. We need to return that. The result is 60 and 70. because now add is working fine with just that one function. Great, isn't it cool? We wrote one function and it's working very well with many other types. One functions for thousands of classes. That's great. This is that function templates. Okay, that's all in the lesson. Thank you very much.